Alright, in section 7.3.2, we're talking about projectile motion. And we are simply going to see an application of completing the square. So we're going to look at a word problem, and we're going to see how completing the square can be used to solve the word problem. Before we get to the word problem, we have to know what the equation is for projectile motion.
Can you record first?
So, projectile motion, the height of an object rising or falling under the influence of gravity, is modeled by the function y equals ax squared plus v sub o x plus s sub o, or s sub 0 we could call it, where s is time in seconds, y is the object's height from the ground in either meters or feet. A is half the downward acceleration due to gravity, and on Earth, A could have one of two values. It could be negative 4.9 meters per second squared, or it could be negative 16 feet per second squared. V sub 0 is the initial upward velocity, again, either in meters per second squared or feet per second squared. And S sub 0 is the initial height of the object in either meters or feet. Now, as you can see here, A has two possible values. Determining the value of A will be based on the word problem that is given to you. If the word problem is in units of meters and seconds, then you would choose the value of negative 4.9 meters per second squared. If the units in the word problem are in feet and seconds, then you would choose negative 16 feet per second squared. So reading the word problem and paying attention to what units are being used will decide, what values you use for A and what units you end up using in your equation. All right, here's our example. Nora hits a softball straight up at a speed of 120 feet per second. If her bat contacts the ball at a height of 3 feet above the ground, how high does the ball travel? When does the ball reach its maximum height? Alright, so some of the key pieces of information here. The ball leaves her bat at a speed of 120 feet per second. So first of all, that's going to be our initial velocity, our v sub 0. And notice that in the problem, they're giving us the units feet per second. So that's also going to tell us the value that we're going to use for A is going to be negative 16 feet per second squared. So again, we're paying attention to not just the number, but also the units. If her bat contacts the ball at a height of 3 feet above the ground, so 3 feet is going to be, whoops, wrong way. 3 feet is going to be our S sub 0, the initial height of the object, in feet, right? So we now know what we're going to plug in for this A, we know what we're going to plug in for V sub 0, and we know what we're going to plug in for S sub 0. So now we can plug all of those in. So let's do it. So we have y equals negative 16x squared plus 120x plus 3. Now the question is asking us, how high does the ball travel? When does the ball reach its maximum height? If you think about a softball being hit from a bat, a softball being hit from a bat is going to go up, and then it's going to eventually level out, and it's going to come back down to the ground, right? So the maximum height of the softball is going to be at the vertex of the parabola. So we have to find the vertex. Well, one way to find the vertex is to change this quadratic that is in general form into a quadratic that's in vertex form. And then we'll get the vertex right from that quadratic. And we'll know how high the ball went and when it went that high. So, we need to do completing the square to change this general form to vertex form. So the first thing I'm going to have to do is factor out this negative 16. And I'm going to get x squared plus, so in this case I have to do 120 divided by negative 16. Right? 120 divided by negative 16 is negative 7.5. So let me actually change this plus to a minus. I factored out the negative 16 from the x squared term and the x term. Now I'm ready to take half of 7.5 and square it. So y equals negative 16 x squared minus 7.5x. Now half of 7.5 squared is 14.0625. So plus 14.0625 plus 3. Now remember, I'm not adding 14.0625. I'm adding 14.0625 times the negative 16 out in front. So when I multiply those together, I get negative 225. So I have to subtract the negative 225. So to simplify all of this, we have our negative 16. What's in parentheses is going to factor into x minus 3.75 squared, and then 3 minus negative 225 is the same as 3 plus 225, so that's plus 228. So we've taken our quadratic in general form, we've done completing the square, now it's in vertex form, where hk is the vertex, h is 3.75, k is 228. That means that it took 3.75 seconds for the softball to reach its maximum height of 228 feet.